All right, welcome back, everyone, for another probability question. Today is July 11th. All right. And we are doing another iteration of a birthday question, kind of building off of what we did in the last one. And this one's about a movie theater. So, we got the movie theater chairs over here, and we got Shang-Chi. I remember seeing Shang-Chi. It was all right. It was okay. Anyway, though, why don't we just step into the problem? At a movie theater, a whimsical manager announces that she will give a free ticket to the first person in line whose birthday is the same as someone who has already bought a ticket. You are given the opportunity to choose any position in line. Assuming that you don't know anyone else's birthday and all birthdays are distributed randomly throughout the year, so 365 days in a year, what position in line gives you the largest chance of getting the free ticket? And the reason I chose this problem for us today is because it does a pretty good job of mixing probability also with algebra, okay? Going back to some of our old algebra things, okay? So, yeah, let's get into the question. So, the probability that we are looking for is two things, right? We want the probability that we share a birthday with someone before us in line. And so, in intersection with that, we want the probability that no two people before us share a birthday. Okay. But as you could imagine, these events are not independent. So we can't just go, if we call this one, this first event, call this guy A, and we'll call this second one. Or maybe I should do a different color. We'll call this second one B. So yeah, these events are not independent. So we're not going to be able to just, do something like the probability of, A. Wow, horrible A. We're not just going to be able to do something like the probability of A times the probability of B. So what we're going to do then is convert our form that we're looking for, PA intersection B. We're going to convert that just to, we're going to convert it to probability A given B times probability B. Okay? And this is just one of our, probability tools. The probability of A and B is equal to the probability of A given B times the probability of B. That's just something that is true that we can say because of Bayes' theorem, which basically says, I'll just write Bayes over here because I guess that's technically what we're using. It basically just says the probability of A given B. Whoops. The probability of A given B is the probability of A and B over the probability of B. Right? And we know this to be true. And so when we do some algebra, we find that the probability of A and B is just A given B times the probability of B. Or we could, of course, also do B given A times the probability of A. But this is the one we're going to work with since it's easier. So getting into it then, what is the probability that we share a birthday with someone before us given no two people share a birthday before us? So let's just assume that there are n people before us, okay? There's n people before us. So if there's n people before us in line, then we are the n plus 1th person, right? This is us in line. So basically, the probability that we share a birthday with someone before us, given that no two people before us share a birthday, basically means that there are how many unique birthdays before us? There are n unique birthdays before us, right? And our birthday is any one of the 365. So the probability we share a birthday with someone before us is going to just be n over 365, right? Because there's 365 days in the year, possible days the birthday could land on. And the probability we have the same as one of those other people is just n over 365, right? Yeah. And if we really wanted to think about this, we could get into the mutual exclusivity of it, right? There are n people, right? So if we just wanted to think about this from a mutual exclusivity standpoint, right? Just said I equals 1, and we're going to go up to n because there's n people. Since, no two people share a birthday, then the probability that we share a birthday with any of them is, of course, just 1 over 365 n times, right? And this is, of course, it's just equal to this. Because all this mutual exclusivity is saying is that, probability we share, if we just called it like A, right? Probability, or maybe I should use a different letter. Probability we share a birthday with person 1, or we share a birthday with person 2, or, so on up through person N, right? And the reason this is mutually exclusive is because we're not ever going to share a birthday with two of them at the same time, since we've conditioned on the fact that none of them share a birthday. So this makes sense. This is the probability that we share a birthday with someone before us in the line. All right. So now we've found probability of A given B. So this probability of A given B is this. Okay. And so we're going to hold on to that for when we multiply by the probability of B. But now we have to go and find the probability of B. So let's get into that, right? So the probability of B is the probability no two people before us share a birthday. And I'm not going to get super deep into this, but we kind of did it in the last video, the birthday problem. And so we use our multiplication rule, and we condition on the fact that person 1 doesn't share a birthday with anyone. So person 1 has 365 options. And because of the multiplication rule, then we say the probability, person 2 doesn't share a birthday with anyone, given that person 1 doesn't share a birthday with anyone. And that would just be 364 over 365. Right? And then for the next person 3, it'd be the probability person 3 doesn't share a birthday with anyone, given person 1 and person 2 don't share a birthday with anyone, would just be 363, right? Because that's the amount of days that remain over 365. And you can see that we do this, okay? We do this up, it's just horrible. We keep doing this up through, person 365 minus n minus 1. I'm just going to separate us off from this because I don't want us to get confused. Over 365, of course. So what is this equal to, right? Maybe you probably remember from the last video this is going to be equal. And even if you don't, you might still be able to follow. So basically what I'm saying here is we start with, I equal to 0. We go up through, all the n people that are before us in the line, which because we're starting at index 0, we only go up through n minus 1. And we're basically doing 365 minus I over 365. And taking, the product of all of these for the people that are in line before us. And we can also say that, this is equivalent to, up through n minus 1, starting at I equals 0, just 1, right? Just 1 minus, basically, I over 365. So, yeah. So now that we have the probability of B here, the probability no two people in the people in the n people of the line before us share a birthday, and we also have the probability that we share a birthday with someone in the line before us given none of them share a birthday. Now we go back to this form that we used earlier, right? Probability of A given B times probability of B. This is probability of A given B. This is probability of B. So now we're going to multiply them, okay? So essentially what we have now is n over 365 times our multiplication, okay? Our multiplication from I equals 0 up through n minus 1 of 1 minus I over 365. Okay, and this was our probability of A given B times the probability of B, or, of course, the original thing we were looking for, the probability no one shares a birthday of the people in the line before us, and that we share a birthday with one of them, and we're just going to call that X, okay? So we have that our probability of X equals this. And now we kind of look at this and we have to wonder, where do we go from here? And we're going to say this is X sub n, actually, because there are n people in the line before us, okay? So it's the probability of X, based on the number of people in the line before us, which in this example is n, right? There's n people in the line before us. So where do we go from here? How do we continue to solve this to find, what were we looking for? The position in line that gives us the largest chance of getting the free ticket. So we have to compare, when we have n people in the line with what if we have, n plus 1 people in the line before us, right? And so let's find a ratio, right? Let's basically say we're going to find the ratio of the probability of getting what we want when there's n plus 1 people before us over the probability we get what we want when there's just n people before us. And basically what this is going to tell us is, what is more favorable, right? Because if our answer here is greater than 1, then we know we have a greater probability of, of this thing coming true when n is greater than 1. And we know that if the answer to this is less than 1, then that is telling us the opposite, right? It means that we have a greater chance of these things coming true when we only have n people in front of us. So when we get into it, right, we rewrite what we have. So we have n over 365. And you know what? Actually, I'm going to see if I can just copy and paste what I have here, because that would be most useful. So basically, yeah, we have this, and we're putting it all over. Oh, but of course it's, plus 1, and then it's only up through n, okay? and because of this plus 1. And it's going to be over just the original. Okay, and so let's look at what this ratio tells us, right? Which one is more favorable for us? Well, let's cross out some things here. So we can cross out, and I'll use a different color to show the crossing out. We can cross out this 365 with this 365. Okay, and we can also say that, you know, the first n minus 1 products here are going to cross out with the first n minus 1 products here. And so they're just going to leave us with the final piece, right? Because this is doing a multiplication of, from I0 to n, and this is doing a multiplication from I0 to n minus 1. So if you just cross out, right, when it just like how you're crossing out these guys, if you cross out all of the pieces from I equals 0 to I equals, n minus 1, and you cross them out here as well, all you're left with is this final piece of n. So I'm going to show you what that looks like here, okay? So basically what I'm saying right now is that we're going to be left with n plus 1 over n, which comes from these two guys, right? Times, it would just be 1 minus n over 365. Okay, so now we have the ratio, right? And what were we saying that this ratio told us? We're saying that if this ratio was greater than 1, then we want to find the values of n, or we're saying that when the ratio is greater than 1, it means this, probability of x sub n plus 1 is more favorable than the probability of x sub n. And so in that case, we want to find the values of n that make that so. So we're just going to set it greater than 1, right? And just assume that that's happening. And then we're going to find the values of n such that that actually does happen. So let's do some algebra here for a second, right? So really what we have is this times this whole piece. I forgot to put it in parentheses, but I should have. And so what that looks like then is, n plus 1 over n, and then it's going to be minus n squared plus n over 365n, which is going to become, let's see here, 365 n plus 365 over, actually everything's going to be over 365n minus the n squared plus n, and we're just setting that equal to 1 to find the values that make it, I'm sorry, greater than 1 to find the values that make it greater than 1. Right? And so let's see what we can do here, to work with this. Okay, yeah. So I was just staring at it for a second there. But basically what we can do with this is just say 365 n plus 365 minus n squared minus n squared minus n, not plus. Oops. All right. Not tripping, am I? No, I'm definitely not tripping. All right. Is greater than 365. And we can, of course, cross these two guys out and say that, negative n squared is, or negative n squared minus n plus 365 is greater than 0, which is what we want to work with for the, quadratic stuff. And then if we just multiply it by -1, we can just say n squared minus n, or I'm sorry, n squared plus n minus 365 is less than 0. Right, and so now we'll use our quadratic equation and basically just, to find n, we're going to say n is equal to plus minus, I'm sorry, not plus minus. It's going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's something we learned back, in algebra in middle school and in high school. And so when we solve for n in that way, right? If I go to my calculator here and I plug this in, I'm going to do -1 plus, let's see, let's just do, oops. I'm going to do -1 plus the square root of 1 minus 4 times 1 times negative 365, and divide that by 2. It's going to get me 18.61. So let's think about what this 18.61 is telling me, right? Or rather, it's not going to equal 18.61. I shouldn't say that because that's it's very misleading and it's going to make us think about it in the wrong way, right? The inequality symbol is still here. N is less than this, and it's less than this as well. So basically, we're saying that when, xn plus 1, the probability of xn plus 1 over the probability of x sub n is greater than 0, or I'm sorry, is greater than 1, which is to say we're favoring xn plus 1, it means that the number of people before us is less than 18.61, right? The number of people before us is less than 18.61. And then basically, then what happens is that, and of course, the second answer, to this, because there's also the minus sign, is negative, but we're just going to set it to equal 0, right? And so in order to get this outcome of n plus 1 people being more favorable, n has to be between 18.61 and 0, right? And what we do with this information is we say that basically once we go greater than 18.61, then this starts becoming more favorable, right? So then the maximum amount of people we want before us would be 18.61, but that obviously doesn't exist, and so we're going to call it 19, right? And if there are 19 people before us, then our place in the line is 20th. Okay, so let's just go to the beginning of the problem, right? What position in line gives you the largest chance of getting the free ticket? It would be when we decide to go 20th, okay? All right, thanks for watching, and I'll see you guys in the next one.